In the calculation of speed and average speed, it is often useful to draw a table. Consider the following example. We can organize the given information in a table. We know that speed equals distance over time. Speed for the journey from Moir to Mersing equals 120 divided by 1.5 kilometers per hour equals 120 times 2/3 kilometers per hour equals 80 kilometers per hour. The speed for the journey from Moir to Mersing is 80 kilometers per hour. The speed for the journey from Mersing to Kulai is 80 divided by 1 1/3 kilometers per hour equals 80 times 3/4 kilometer per hour equals 60 kilometers per hour. The speed for the journey from Mersing to Kulai is 60 kilometers per hour. When calculating Jack's average speed for the whole journey, we need the following formula. Average speed equals total distance over total time. First, we need to find the total distance and the total time. 10 minutes equals 1/6 of an hour. Total time taken equals 1.5 plus 1 1/3 plus 1/6 equals 1 3/6 plus 1 2/6 plus 1/6 equals 2 6/6 equals 3 hours. The total time taken includes the rest time, which is 3 hours. The total distance is 200 kilometers. Thus, Jack's average speed is 66 2/3 kilometers per hour. Here is another problem. Can you solve it? A motorcyclist took 1.5 hours to travel 143 km. Sometimes we can use diagrams to help us. Let us examine the following problem. At 10:30 a.m., a van started traveling at 60 kilometers per hour from town A towards town B. Half an hour later, a car started traveling at 90 kilometers per hour from town B towards town A. The van passed the car traveling in the opposite direction at 12:30 p.m. How far was town A from town B? We can use a diagram to help us visualize the problem. Can you find the distance the van had traveled when it Can you find the distance the car had traveled when it was 12:30 p.m.? Can you deduce the distance from town A to town B? When the car reached town A, how far away was the van from town B? How long did it take the car to reach town A? For how long had the van traveled when the car reached? How far away was the van from town B when the car reached town A? A distance time graph is a line graph that is used to describe the motion of objects such as cars, trains, motorists and cyclists. The distance traveled is represented on the vertical axis, and the time taken to travel that distance is represented on the horizontal axis. This distance time graph describes the journey of a cyclist starting off from home. The graph illustrates 5 parts of his journey. He travels a distance of 20 kilometers away from home at a constant speed in the first 2 hours. He has his tea break from 10 a.m. to 11 a.m. Thus, the distance covered is 0 kilometers as the bike is not moving. From 11 a.m. to 2 p.m., he continues another 40 kilometers of the journey at a constant speed. He then takes a lunch break from 2 to 3 p.m. Thus, the distance covered is 0 kilometers, as the bike is not moving. From 3 p.m. to 5 p.m., he travels towards home at a constant speed. Notice that the steepest section in the graph is EF. This indicates that he cycles at the fastest speed from 3 p.m. to 5 p.m. Anne jogs to the Botanic Gardens from home every weekend. Along the way to the gardens, she stops to exercise at the fitness park before continuing. After arriving at the Botanic Gardens, she jogs back home. The travel graph below describes her journey. How far does Anne jog each weekend? How much time does she spend exercising at the fitness park? How far is the fitness park from the Botanic Gardens? What is the average speed for her whole journey? The diagram shows the travel graph of a van and a car traveling from town A to town B. Study the graph carefully and answer the questions. How far was town A from town B? What was the speed of the van in the first 2 hours? At 12 noon, which vehicle was ahead? How far ahead was it? At 1000 hours, a lorry set off from town B and travelled at a constant speed, arriving at town A at 1400 hours. Find from the graph at what time it met the van and the car travelling in the opposite direction.